Hey guys, it's Miss Cubitt here. In this lesson, I'm gonna be teaching you about probability and specifically sample spaces and what sample spaces are. I'm going to be using a resource for the notes in the video, and that's a resource created by Maneuver in the Middle. So I just want to, for copyright reasons, I do not want to claim the resource as mine, but I am using it to help with the lesson. So the lesson is sample spaces. The sample space describes all the possible outcomes of an event. It can be displayed with lists, tables, or tree diagrams to determine the probability of the simple, if I can spell, or compound events. So that's the definition, that's what a sample space is. It's all the outcomes, and we display it with lists, tables, or tree diagrams. For example, number 1, the New England Patriots and the Dallas Cowboys are playing. What are the outcomes? Well, if you play a game, the outcome is the Patriots win, and the Cowboys lose. Is that the only outcome? No. For some miracle on earth, the Cowboys could win, and the Patriots could lose. So those are the outcomes. So how many outcomes are there? 2 outcomes. Patriots or Cowboys win. If I have a number cube, on a number cube, let me draw ourselves a cube. We have either a 1, 2, 3, 4, 5, or 6 on the cube. So the possible outcomes is that I could roll a 1, or I could roll a 2, or a 3, or a 4, or a 5, or a 6. So how many outcomes are there all together? There are 6 outcomes. Those are sample spaces. So let's try a few more. Another example. Another example is I have 2 spinners, and I spin them at the exact same time. I can use a tree diagram to represent my sample space. So my tree diagram would be, if I have a 1, if I spun a 1, I could have a 1 be a yellow, the 1 be a blue, the 1 have a red, or I could spin a 1 and get an orange. But I could also spin and I could get a 2. If I spin for a 2, I could have a yellow, I could have a red, I could have a blue, or an orange. And in this tree diagram, as it looks like a tree with branches, I notice that I have 4 outcomes with a 1. I have 4 outcomes with a 2. And that means I have 8 total outcomes. That is using a tree diagram. But if I look, I can notice a pattern. So I want you to kind of look at this pattern and hold it with you, because I'll explain the pattern on the next problem. So I'll give you a few seconds to see if you can see a pattern. Okay, so let's try one more, and then I'll explain. Hopefully you'll get the same reasoning that I got. When buying a car Esther could choose a 2-door or 4-door car with leather or cloth interiors in black, silver, or white. What are all the possible combinations of our car selection? This time, I'm going to draw a table. And on the first column, I'm going to put my 2 cars. I have either a 2-door or a 4-door. And then I could have it either a leather or a cloth in each one. And in each one from there, I could have a black, silver, or white. Uh-oh. I made a little mistake. And I'm not ashamed of making a mistake. Because it says the leather or cloth in. So leather could have black, silver, or white. Or the cloth can have black, silver, or white. But again, I could have it again here. Black, silver, white, black, silver, white. So all together, my different combinations I could have are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 total combinations. Now, the pattern. If I do not want to draw out the entire sample space, I can also find the combinations mathematically. I could do that by counting my combinations. I start off with 2 choices, and then I have 2 more choices. And then, by 3rd row, I had 3 choices. So 2 times 2 equals 4. 4 times 3 equals 12. And I had 12 at the end. So that is another method of finding your combinations. I hope this helps explain what sample spaces are and how you can use the different representations of a table, a tree, or a list to find out the total outcomes a situation may have. I hope you have a great day. Leave any comments, like and share the video if it helped. Bye.